What are the first principles for proving geometry theorems? Imagine trying to build a house without knowing what bricks or nails are. You need a solid foundation to make sure everything stays together. In geometry, that foundation is made up of basic ideas called first principles. These are the starting points from which all other truths are built. Think of them as the rules of the game that everyone agrees on before playing. When mathematicians prove a theorem, they relying on these principles to make sure their reasoning is correct. The first group of principles are definitions. These tell us exactly what shapes and objects are. For example, a point is a location with no size, a line is a straight path that extends forever, and a triangle is a shape with 3 sides. Definitions help us understand what we are talking about and avoid confusion. They are like the labels on a box that tell us what's inside. Next come postulates or axioms. These are statements we accept as true without proof. They are the basic rules of geometry. For instance, through any 2 points, there is exactly one straight line. Or, if 2 lines cross, they meet at 1 point. These postulates are like the rules of a game that everyone agrees to follow. They let us make logical steps to prove new facts. Then there are common notions, which are general ideas used in all of mathematics. These include ideas like things that are equal to the same thing are equal to each other. Or, if you add the same amount to 2 equal things, they stay equal. These principles help us manipulate and compare shapes and sizes during proofs. All these first principles work together to create a logical framework. When proving a theorem, you start by stating what you know and what you want to find out. Then, you use definitions, postulates, and common notions to make logical steps. Sometimes, you draw extra lines or triangles to see relationships more clearly. Each step follows from what you already know, making the proof solid and convincing. This method shows that geometry is not just about measuring shapes but about reasoning carefully from clear, agreed-upon ideas. These principles help us understand properties of triangles, circles, polygons, and more. They are the tools that allow us to prove that certain facts are always true, no matter what specific shapes we are working with. Whether in architecture, engineering, or computer graphics, understanding these first principles makes solving geometric problems possible and reliable.